Thanks for tuning in. I want to give you my latest update on my trash drone. And first, I'll give you a quick intro into what it is, just in case you haven't been watching. Hey, I want to give you the latest update on my trash drone. I fly a drone around the streets of San Francisco. Whenever it comes across a pile of trash, it files a request with 311, which alerts the Department of Public Works to come out and clean it up. In my last video, I successfully got my model to detect trash piles with 95% accuracy. One pitfall that I ran into was that it was detecting trash piles in the streets, sidewalks, but also in people's backyards or on the rooftop. The trouble with that is that DPW is not going to come out and clean up someone's backyard or the rooftop. I came up with an idea. Using Detectron2 to mask out everything except for the sidewalks and roadways. Cue the music. Let's get into some details. Why Detectron? And to answer that, I first need to talk about what is Detectron. Detectron2 actually, is a library by Facebook Research that contains several cutting-edge detection and segmentation algorithms. Of particular interest to me is the TensorMask implementation. TensorMask allows you to draw a mask around specific objects using AI. In my case, I want to exclude everything except for the sidewalks and the roadways, so I'm masking the sidewalks and the roadways, and then I'll apply some sort of inversion to that. The result will be images that only contain sidewalks and streets. To answer the question of why did I use Detectron, it's pretty simple. One, it works. It's very easy to use. I tried a couple different libraries. This one worked right out of the box. Two, it supports the latest GPUs. I'm running on the latest RTX 3090s, and it supports those out of the box without any modifications to the code. So that's why I chose it. I was able to achieve moderate success using Detectron2 in only a day or two of effort. I loaded in my own custom dataset with my own annotations of the roadways and sidewalks. Those annotations and images look something like this. In fact, these are examples. I did some setup of the COCO trainer using fast RCNN as the basis, and then also pointing it to my custom dataset. So it's using a set of weights that have been pre-trained on COCO images. And then I'm also taking my custom data set, which is only about 60 to 80 images. I'm allowing the weights that I got from the COCO detection model to be adjusted. You might be wondering, what is COCO? COCO is a large-scale object detection, segmentation, and captioning data set. So it's just a really big set of images that have lots of different labels, 80 object categories, 91 stuff categories, and over 1.5 million object instances. COCO is a great starting point. I'm pretty much just adding my images, my 80 images, at the very end of the training session so that it retrains the final layers of the neural network. It uses all of the prior learnings in the previous layers from being trained against COCO. So here are a couple important pieces of code. Right here is where I set up my data set. I'm pointing it to my annotated train, validation, and test data set. Detectron requires you to register your data set. So if you're bringing your own custom data set, you're going to need to register it. And that can be done with a few lines of code. Here I'm setting up the configuration. That's things like setting the learning rate, the number of workers, telling it which data set to use, which is the one I just set up, giving it like its base set of weights, which is based on RCNN, setting up things like batch size and whether it should mask, create the masks. So I had to turn masking on. I trained my model on my data set and I got some good results. Here are the results from my model after training it and running it against my test set. Boom, boom, boom. These look really good. For the most part, they're pretty decent. I think they do the job. I can always improve them with more images, with more annotations, and I think that's what I'm going to do. But I'm really pleased with the results here. I'm going to keep working on this model. The next step is to collect more images and annotate them. I'll do a couple more training runs once I have more images and continue to do that for the next couple days. Once that plateaus out a bit, then I'll start working on tuning the hyperparameters a bit. Well, that's been it for today. Thanks for tuning in. And I'm having a blast flying the drone around. So here's some footage that I've taken of the Bay Area while I've been flying around and getting images of garbage.